everyone, welcome to Math TV with Professor V. This is video lecture number 35 for intermediate algebra, and we're going to talk about dividing radical expressions. Now, building on the last video, we looked at the product rule for radicals. So we've already seen that if you have the nth root of AB, so you have a product under the radical sign in the radicand, you can break it up and write it as nth root of A times nth root of B, as long as A and B aren't negative. And a similar property holds for quotients. So here's the quotient rule for radicals. Again, for non-negative real numbers A and B, we have the following, that the nth root of A divided by B is equal to the nth root of A over the nth root of B. So basically you can split up a radical sign over division as well. So let's use that rule to simplify some of the following radical expressions. First one, we have square root of 10 over 49. So split them up, give them each their own radical. Square root of 10 over square root of 49. And then let's check, can this be simplified further? Because remember in the last lesson we learned how to simplify radicals. Well, square root of 10, no, that doesn't simplify. No perfect squares divide evenly into 10, but square root of 49 is 7. So I'm going to box this and call it a day. There's our answer. Okay. It's an ugly little box, and I don't like it. All right, we're just moving on. Okay, B, 8 rad 50 over 4 rad 5. So now we're going to go the other way, actually. You see how we already have two radicals? Well, we're going to combine them into one. So basically, it's like going from that side of the quotient rule the other way around. So what I'm going to do is write this as, well, 8 divided by 4, that simplifies to 2. And then I'm going to have one big radical for 50 over 5. And then you can simplify now underneath the radical, perform the division. 50 divided by 5 is 10. So this is 2 radical 10. Okay, good. C, we have rad 56ab cubed over rad 7a. So notice already we have two radicals, so we should go the other way, put it together, and see if we can simplify. So one big radical, 56ab cubed over 7a. So let's simplify the constants first. 56 divided by 7, we know that's 8. A cancels out, right? See that? Bam, bam. And then we have b cubed. And then now we're going to break this down further. So if you'll remember from the last lesson, 8, you want to factor that using the largest perfect square that goes into 8, which is 4. So I can write 8 as 4 times 2. And then b cubed I'm going to write as b squared times b. Why do I do that? Well, notice square root of 4 and square root of b squared are going to come outside the radical. Okay, so we're going to have 2b. And then we have here radical, what's stuck underneath? Another 2b. All right, and you might be thinking, wait a minute, you didn't put absolute value around the b, and the last couple lessons you made a big deal that square root of b squared was absolute value of b. But remember, this quotient rule for radicals only applies for non-negative real numbers a and b, so I don't have to worry about b being a negative quantity. Okay, very good. Now, a lot of the times with working with radicals, or just in general in your math classes, the directions will be one little word, simplify. And that can be overwhelming because it might seem vague. So here's just a checklist for you to keep with you. Anytime you see something where the directions say, hey, just simplify, this is what it means. So first condition, all factors that can be removed must be. What do I mean by that? Like you would not leave this as radical 8 because the factor of 4, which is a perfect square, needs to be removed from the radicals, okay? Second condition is that there are no radicals in the denominator. cannot have a radical in the denominator of your expression. The numerator is fine. The last one is no fractions are allowed inside the radical. Okay, so we'll see how to fix that if it's an issue. Okay, so what I want to focus on right now, because we're pretty good at, removing factors, removing perfect squares, perfect cubes like we did in the last lesson. But the second one right here, no radicals in the denominator. We're going to practice taking care of this. And it means it's often necessary to rewrite a radical expression using a process called rationalizing the denominator. That's basically what it means to remove the radical, okay? Rationalizing the denominator. And to do this, we use our old idea of rewriting fractions by multiplying by a carefully chosen form of the number 1. And I want you to recall at the end of the last video, we noticed if you have the square root of x times the square root of x, assuming x is not negative, you get back x. Okay, and so that's the idea that we're going to use here while rationalizing. Okay, so let's look at an example, A, and the directions just say rationalize the denominators. We have 3 over square root of 5. So no square roots are allowed in the denominator. When you're going to rationalize the denominator, you multiply by the radical expression that you're trying to get rid of once it's simplified. So that means, rad 5, I don't want you, so multiply by a rad 5 down here. And then you can't just go willy-nilly multiplying, denominators of fractions by rad 5. So you got to multiply by a rad 5 in the numerator as well. That way you're actually multiplying by 1. So you're not tampering, right, with the value of that quantity right there. Okay, lovely. So in the numerator, we have 3 rad 5, just like that. And then in the denominator, notice, I'm going to do this off to the side. Rad 5 times rad 5 is rad 25. Which just comes out to 5. So basically, when you have a radical and you multiply it by itself, the square root goes away. That's because rad 5 times rad 5 is also the same as rad 5 squared, which is 5. So I don't typically show this when I'm rationalizing the denominator because I'm so comfortable with it. I know, okay, rad 5 times rad 5, boop, it's just a 5, okay? If you're getting used to the process though, okay, write out more steps, but it's not necessary. Okay, let's look at another. 12 divided by rad 3. So what am I trying to fix in the denominator? I don't want that radical 3, so that's precisely what I multiply by. Rad 3, and then looks like the numerator is going to need to get the same thing. So now we're going to have 12 rad 3 over what's going to be in the denominator? Good, just 3. Whoa, before you box it, notice you can simplify. 12 divided by 3, that gives me a 4. So we have 4 radical 3. I could simplify that 12 and 3 because they're both not under the radical. Okay, you can't reduce or cancel fractions if one of the constants is under the radical and the other one isn't, okay? Good. Next one, example C, we have 7 over rad 12. Oh, please be careful. Rad 12 is not simplified now, is it? No. Rad 12 is square root of 4 times 3. So this is 7 over 2 rad 3. Always simplify first as much as you can under the radical. Because maybe if you got carried away, you would have multiplied by rad 12, right? Don't do that. No. It'll just make things much messier, and then you'll have so much more simplifying to do at the end. So simplify early on. Okay, now it should be clear. We need to multiply by rad 3. So what do we have here? 7 rad 3 over the 2 stays, and then rad 3 times rad 3 is 3. So your final answer should be 7 rad 3 over 6. Like that. Beautiful. How are you guys doing? Good? Oh, wonderful. Okay. Let's look here. Rad 5 over 18. Well, 5 over 18 doesn't reduce. And remember, one of our rules for simplifying is there's no fractions allowed underneath the radical. So let's go splitting these guys up. We're breaking them up. Rad 5 doesn't simplify. Does rad 18 simplify? Yes, it's 9 times 2. So this is rad 5 over 3 rad 2. Are you able to do that in your head? You should be getting more proficient by now. Okay, so I need to get rid of the rad 2 in the denominator. I'm not worried about the radicals in the numerator, okay? And then let's see what we're going to have here. So in the numerator, notice both this 5 and 2 are underneath the radical, so we can combine them together. 5 times 2, that's 10. And then here the 3 just comes along for the ride. Rad 2 times rad 2 is 2. So we have rad 10 over 6. That's it. I can't simplify any further because the 10 is under the radical, the 6 is not. So you can't go reducing anything, yeah? Okay, very good. E, we have rad 36 over rad 18. There's a long way and a short way to do this. Yeah, you can actually combine them under the same radical. Did you notice 36 divides evenly by 18? That's 2, and we're done. Oh, that was a pleasant surprise. What if you didn't notice that? Oh, it would have taken you some more work. If you didn't notice and you were like, oh, that's 6 over 18 is 3 rad 2, then you'd multiply by rad 2, wouldn't you? Then you'd have 6 rad 2 over 3 times 2, which is 6. Cancel, cancel, cancel. Rad 2. So you would get there. But like I said in the last video, it took you quite a few more steps. You're not doing it the most efficient way possible, yeah? And you're probably the kid running out of time at the end of the exam. So it's on you. All right. Last idea, okay? It can be a little trickier to rationalize with cube roots or higher roots. But all you have to do is match the number of factors underneath the radical with what the index is. Okay, so for example, if you have cube root of 2 right here, and you want to get rid of that, you don't just multiply by another cube root of 2. You would need 3 2's, right? You would need the cube root of 2 cubed to get back a 2. So make sure, since I noticed the index here is a 3, yes, this is a 3, that means I need 3 copies total of the factor underneath the radical sign. So I need to multiply by another cube root of, and I list them out like this, 2 times 2. That way it's really clear to my brain. I got 1, and then now I'm adding 2 more. You decide what to multiply by based on the denominator. And then whatever that ends up being, you write the exact same thing in the numerator so that you're only multiplying by 1, so that you're being fair. Okay, good. Now you clean it up. I know it looks a little ugly. We have 5 cube root of 4 over cube root of 2 times 2 times 2 is 8. Or I could have written 2 cubed, doesn't matter. And then we're done. So we have 5 cube root of 4 over 2. Again, you can skip this step right here if you're certain that you did this nicely and that you have exactly 3 copies of 2, cube root, you should get back 2 in the end. Okay? Good. Example B is a wee bit trickier. Here we have cube root of 9. Before you get going, I want to point out 9 is not written according to its prime factorization. You're like, huh? 9 is 3 squared, is it not? So I didn't want you accidentally writing by cube root of 9 times 9. That would just be way too much, and then you'd have so much simplifying to do in the numerator. Things would get nightmarish. So whenever you have some quantity underneath the radical that's not a prime number, break it down into its prime factorization, meaning write it as a product of prime numbers, okay? Raised to the appropriate powers. So now look, oh, I already have 2 factors of 3, 2 copies of 3. We're taking a cube root. I only need 1 more. So I only need one more cube root of 3, okay? And then you're going to multiply by the exact same thing in the numerator. The denominator is just going to end up being 3. You could write cube root of 27 if you're so inclined, but you know, I think it's obvious because we're careful little mathematicians here. So we're left with 7 cube root of 3 over 3. That's it. Very good, very good. I got one more for you. It's the spiciest one of the lesson. We have cube root of 3 over 25x. Split that cube root over the numerator and denominator. So we've got cube root of 3 over cube root. Okay, you guys, were you paying attention? How should I rewrite 25? 5 squared times, I'm going to put x to the first just to help you, okay? Good. Let's tackle things one term at a time. So we don't want radicals in the denominator. I need 3 copies of 5 to make that happen. So I need cube root of, I need one more, 5 to the first. And then look, I only have one factor of x, but I need 3 total. So I'm going to need x squared, 2 more. Whatever you multiply by in the denominator, you multiply by in the numerator. So cube root of 5x squared. Okay. So now let's see what's going on. I know in the denominator, I'm just going to have 5x. It's just 5x. I don't need to write any more. For a hot second, it's the cube root of 125x cubed. Who cares? We set it up to be just that. And then in the numerator, okay, look, make sure you're writing your index of 3. And then we can multiply the radicands by each other. So we're going to have cube root of 15x squared. Like that. Okay. And I did say we would do some higher order ones and we didn't. What a liar I am. So let me just throw in one more bonus. Say you had 4 over the 5th root of x squared. Oh, I know. Look at this. So the index here is 5, which means I need x to the 5th. I need 5 copies for it to break free from the radical bondage. So I'm going to multiply by 5th root of, I need 3 more, yes? Wonderful. Whatever goes in the denominator goes in the numerator. Okay, so down here, this is 5th root of x to the 5th. So I just have x. And then in the numerator, it's just those 2 terms, 4 times the 5th root of x cubed. Look at that. That was advanced. Certainly not all your friends could do this. Be proud. You could show them at your next Saturday night party. Look at me simplifying radicals. So that concludes the lesson. Short and sweet, yes. Subscribe if you haven't already. I would love your support. Give this video a thumbs up if you found it helpful. And I have so many more videos all the way through calculus 1, 2, and 3, differential equations, linear algebra are in the works. Also, if you'd like access to exclusive content or videos, topics on demand, join my Patreon. I'll put the link here. And I have more algebra videos coming your way. I feel like even the advanced math students need a good review. So I'm happy to make them and they're fun for me. They really are. All right, guys, have a great one. Talk to you soon.